Hi there. This is section 4.2, the Introduction to Regression, and I wanted to go over question number 53, the SAT scores, which is on page 182. This is a homework question. So the question gives you the information for the SAT scores for the reading score and the math score for 5 different states: New York, Connecticut, Massachusetts, New Jersey, and New Hampshire. So here are the reading SAT scores, and here are the math SAT scores. And in this case, the problem wants you to use the reading scores as a predictor of the math scores. So reading is X and math is Y. But it could have been the other way around. You could have been interested in whether the math scores predicted the reading scores. So this assignment of X and Y is somewhat arbitrary in my opinion. But this is the way they want you to do it. So question A says calculate the slope B1 and the y-intercept B0 of the regression line. So your book uses this formula for the regression line. That's their notation. So I recommend that you do this on your calculator. So you're going to want to enter this list into L1, the y's into L2. You're going to want to hit Stat, Calc, Linear Regression, L1, L2, and Enter. You really want to learn how to do this on your calculator, so that's a separate video using the calculator. But once you enter that information and hit Enter, it should spit out a regression line for you. So you should get something like y hat, I think it might just say y, equals 0.43x plus 298.86. So I did this on Excel. Here's my little fancy scatter plot. So here's the reading score, here's the math score. The dots represent each one of those 5 points, and Excel gave me the regression line right there. It's 0.4. Excel says 0.4264 plus 298.86. So you can see that that's a mildly strong positive relationship, which is what you would expect, that when the reading score goes up, the math score goes up for those people really good at taking the SAT. So B1, which is the slope, is 0.43. I think your calculator calls that A. B0, which is the y-intercept, is 298.86. I think your calculator calls that B. So just make sure you know the notation. The next question, part B, says state the regression equation in words that a non-specialist would understand. You know, someone who hasn't taken stats. So here's the regression equation. Y hat equals 0.43x plus 298. So in this case, Y is the math score and X is the reading score. So what they want you to write is a sentence that looks like this. The math score is equal to 0.43 times the reading score plus 298.86. I'm not sure a non-specialist would understand this either, but here it is. What we're saying is that the SAT math score is 0.43 times the SAT reading score plus 298.86. Hi, Meredith. It's my daughter. Interpret the value of the slope of B1. So the slope, B1, we just calculated, is 0.43. So how you interpret this value, if we go back to our scatter plot, so the slope represents how steep a line this is. So it's going up a little bit. We're saying for every time you go over one score in the reading score, you're going to go up. You get an increase of 0.43 in your math score. So the way you interpret the slope is every increase in 1 point for the SAT reading score means an increase in 0.43 in the SAT math score, according to our equation. Part D says interpret the value of the y-intercept. So the y-intercept we calculated is B0 equals 298.86. So again, if we look at our scatter plot, here's the regression line. The y-intercept would be where this line continues down to hit the y equals 0 axis. So we're saying that line is going to hit y equals 0 at 298.86. That means if your reading score is 0, the predicted math score is 298.86. Why is your reading score 0? Why did you only score 298.86? I don't know. Maybe you forgot to show up for the reading section. Maybe you don't speak English, and that was very confusing. So it's sort of a silly prediction in my opinion. But what you would say is for an SAT reading score of 0, you would predict an SAT math score of 298.86. A very precise, if not somewhat silly, number. And then I added some extra special questions. Part E, your book does not have a Part E. This is Kate's special Part E. It says, for a test, you might be asked to predict the SAT math score for a reading score of 515. So here's our regression equation. Here it is on the line. So we're going to use the line for prediction purposes. So if we wanted to know, okay, suppose someone scored 515 on the reading, what would their math score be? You answer this by taking 515 and plugging it into that equation. So we get y hat equals 0.43 times, so I'm going to plug x right in there as 515, plus 298. Algebra equals 520.31 as a math score. So we're saying we would predict, according to our line, according to this line, if you plug in 515, the point on that line should be 520.31. So another question I could ask is find the prediction error for a reading SAT score of 515. So in order to calculate the prediction error, you need the observed value and the predicted value. So in this case, I'm going to move my pretty scatter plot. We have the observed value. So when x was 515, we have the observed value of y here is 515. Come on, yellow. Yellow, observed value. This right there is our observed value. So if we go to this prediction error equation, the observed value was 515, the predicted value was 520.31. So the prediction error, you take y minus y hat, you take off your hat, that's how I think of it, 515 minus 520.31, so the prediction error is negative 5.31 for a reading score of x equals 515. Oh look, one more question. See how generous I am in my extra question giving? Interpret the prediction error. So here's a few different ways you could state this prediction error. Because the prediction error is negative, we see that our prediction is 5.31 points too high. All right, maybe that's confusing. You could also phrase it this way. The observed value is 5.31 lower than the predicted value. So if you look at the scatter plot, I have to bring it back. Come on back. Oh, it doesn't like it when I do this. Equals y. There. That'll fix it. Here's my scatter plot. So if you pick 515, we're saying the predicted value is the point on the line, the observed value is that dot, and the prediction error is the distance between the dot and the point on the line. I wish I could put the dot on the line, but so that distance is 5.31. So because the dot is below the line, that prediction error is negative. So the negative prediction error tells us the dot was below the line. So another way to say that is we see that the observed value is, the dot is the observed value, is 5.31 points below the predicted value, or 5.31 points below the regression line. And that's how you could interpret the prediction error. So that's one long regression question, and you should be able to do something like this on the test.